Hello everyone. Today we are going to take a look at the quotient remainder theorem, the vocabulary that we need to use, and the mechanics we will use to solve some problems using the quotient remainder theorem. So we will use the quotient remainder theorem to look at problems like this, of 3,465 divided by 5. The first thing we want to do here is think about how we would look at division, say when we first learned it in elementary school. So we've got this helpful little line here, and we've got our dividend is our number that's being divided, so it would be that 3,465. Our divisor is what we are dividing by. Our quotient is what is our result, and we will deal with any remainders later. It's important to know this vocabulary because even though dividing 20 by 4 is something that we all know how to do, in order to build upon that, we need to make sure that we have the proper vocabulary for moving forward. So we see this in a number of ways with our division sign, with the little corner that we're going to use for some long division, or as a fraction, all of which we are going to see moving forward with both the quotient remainder theorem and dividing polynomials. In order to use the quotient remainder theorem, we might need to do some long division. As a review, let's take a look at how we are going to long divide. We have this where it's the same as 44 divided by 2, and 44 is our dividend, 2 is our divisor. How we use long division is we look at the first digit and we are going to divide 4 by 2. We ignore the second 4 for now, and we will come back to it later. So 4 divided by 2, and then we write 2. There's our quotient that we write up above our division box. So then we multiply our quotient by our divisor. 2 times 2 is 4, and write the product here. You subtract your product of your divisor and your quotient from the digit or digits, as we'll see in another example in the divisor, and then you write that result down. You bring down your next digit in the divisor and do the same thing. 4 divided by 2, and our quotient is 2. We multiply that 2 by the 2 in our divisor, and then we write that here, subtract that product from what's remaining in our dividend. This 0 is going to be our remainder. Let's look at one where it's going to follow some slightly different paths. So here we're dividing 495 by 5. We go and try and do 4 divided by 5, and our quotient is going to be 0. If we start out with a 0, we don't need to write that. But then what we'll need to do is, instead of looking at 4 and dividing it by 5 and writing the quotient, we look at 49 divide by 5 and find the quotient. So 49 divided by 5 is 9, because 9 is our multiple, 9 multiplied by 5 gives us 45, which is our multiple of 5 that is less than 49. That's going to be important with our quotient remainder theorem. So then we subtract that 45 from the 49, and our remainder is going to be 4. We bring down our 5, and now 45 is our new dividend, and we divide that by 5 again. So 45 divided by 5 is 9, and we still end up with a remainder of 0. So we've got our dividend, our quotient, our divisor, and our remainder. These terms are all very important for when we look at the quotient remainder theorem, which is another way of officially writing this out. So here, our quotient remainder theorem, we have A is equal to D times Q, where A is our dividend, D is our divisor, and Q is our quotient, plus our remainder. So think about it in that first problem that we did. Our dividend was 44. Our divisor was 2. Our quotient was 22. And then our remainder was 0. So this is just a true statement because we have already done the division. Here we can take a look and see what types of problems we will start off with the quotient remainder theorem. So use the quotient remainder theorem to determine integers q and a when a is equal to 87 and d is equal to 7. That's just a long way of writing out when you divide 87 by 7, what's the quotient, what's the remainder. That's what we're looking for, just written in this way to use the quotient remainder theorem. So we write this out. 87 is our dividend. Our divisor is 7 multiplied by some quotient. We don't know what the quotient is yet. And then plus some remainder. So what we need to do is pick a multiple, our multiple of 7 that is less than 87. Okay, so 7 times 11 is 77. So 7 times 8 is 84. Okay, great. Let's do that. So our quotient is going to be 12. So what we do is 87 is equal to 7 times 12 plus r. And then we multiply that 7 and 12, end up with 84. Then we just solve for r by subtracting 84 from both sides. And then our remainder for this problem is going to be 3. Now, the reason that this can be a little tricky and we need to take a look at our exact structure here is when we have negative values that we are dividing by. So we have our a value is negative 16. So negative 16 is equal to our divisor of 3 multiplied by some quotient plus some remainder. We need to find our multiple of 3 that is less than negative 16. What trips people up sometimes is you take a look at this and go, oh, well, negative 16 divided by 3, well, we've got negative 5 with a remainder because negative 15, right, and then we go from there. That is not how it's going to work with our quotient remainder theorem. Our remainder has to be positive. So what we do is if we said that our multiple of 3 was negative 15, so our quotient would be negative 5, when we added 15 to both sides, we would get our remainder to be negative 1, which is not okay for our quotient remainder theorem. So instead, we have to look at these same rules where our multiple of 3 that is less than negative 16, which is negative 18. Just how negative numbers work, because negative 18 is less than negative 16, especially if we're moving quickly, we might not be thinking of that exactly. So our multiple of 3 is going to be negative 18, so our quotient is going to be negative 6, and then let's solve this equation to find our remainder. So we add 18 to both sides, and our remainder is going to be 2. Thank you for watching.